Generative AI versus LLMs, a deep dive into the engines of machine creativity. Imagine asking a machine to design a fashion line, compose an orchestral score, write a heartfelt letter, or draft a legal contract, and it delivers with precision and creativity. Now imagine another machine that talks to you like a friend, writes stories, codes software, answers technical questions, and even helps run your business. Both are examples of generative AI. But while one is broadly trained to create across many media types, the other, a large language model, LLM, focuses on mastering human language. They seem similar, but under the surface, their design, capabilities, and use cases diverge in significant ways. So what's the difference between the two? How do they work? And more importantly, how can you use them to your advantage? In this comprehensive guide, we'll break down the world of generative AI versus LLMs to help you understand, compare, and ultimately leverage both in work and life. Generative AI refers to artificial intelligence systems capable of creating original content based on patterns learned from existing data. These systems don't just analyze, they generate. Unlike discriminative models that classify or label input, generative AI creates entirely new outputs such as images, music, video, 3D models, and even synthetic data. Key characteristics of generative AI include several fascinating aspects. First, creative output. It generates novel content that can rival human creativity. Then, cross-modal abilities. It works across various data formats: text, images, audio, and video. Next, self-learning capabilities. It continuously improves with access to new data. And lastly, user-driven input. Simple prompts can lead to complex, tailored outputs. Let's talk about some famous tools. DALL-E turns text prompts into vivid artistic images. Runway Mel provides video and image editing and generation capabilities for creators. Musical.ly composes music across styles, moods, and instruments. And StyleGAN generates hyper-realistic faces of people who don't exist. Now, let's explore some real-world applications. In entertainment, AI-generated film scenes, animations, and music are revolutionizing production. In fashion and retail, virtual try-ons, concept designs, and dynamic product visualization are becoming the norm. For interior and product design, 3D mock-ups, prototype models, and augmented reality previews are incredibly useful. And in healthcare, generating synthetic medical images is enhancing diagnostics and training. A large language model, or LLM, is a specialized branch of generative AI designed to process and produce human language. Trained on terabytes of text data, LLMs are optimized to perform a wide range of language-based tasks, answering questions, writing essays, translating languages, creating dialogue, and even reasoning. Core capabilities: text completion, finishing sentences and paragraphs based on initial input. Conversational AI sustained, contextual conversation across topics. Summarization, condensing documents into concise, relevant takeaways. Sentiment analysis, determining tone, emotion, and intent in text. Code generation, writing, explaining, and debugging software code. Famous examples: ChatGPT by OpenAI, known for its fluency, creative output, and wide applicability. Bard by Google integrates search engine functionality with generative capabilities. Claude by Anthropic focuses on safe, reliable, and user-aligned interaction. Llama by Meta provides open-source LLM access for researchers and developers. Real-world applications: customer service. Virtual agents capable of intelligent, empathetic responses. Legal research. Summarizing cases and suggesting legal arguments. Healthcare support. Generating patient notes. Simplifying medical terminology. Software development. automating repetitive coding and documentation tasks. While both generative AI and LLMs are designed to create new content, they serve distinct purposes and operate in different ways. Generative AI encompasses a wide range of modalities. It's capable of creating not just text, but also images, audio, video, three-dimensional models, and more. This makes it ideal for use cases like digital art, music generation, or virtual reality environments. The models that power this form of AI include GANs, or Generative Adversarial Networks, VAEs, which are variational autoencoders, and diffusion models, each suited to different content types and fidelity requirements. In contrast, LLMs are a more specialized subset of generative AI, focusing entirely on language. These models, such as GPT, BERT, and their successors, use transformer-based architectures to process and generate human-like text. They excel in tasks that involve reading, writing, or interpreting language, such as answering questions, summarizing documents, coding, or even simulating human conversation. While LLMs only take text as input, generative AI can work with multiple types of media, including sketches, photos, and voice commands. Put simply, generative AI is the umbrella under which LLMs fall. Generative AI provides the tools to design visuals, sounds, and virtual worlds, while LLMs deliver the power to narrate, instruct, reason, and explain in natural language. Depending on your goal, whether it's to illustrate, compose, or communicate, choosing between the two, or combining them, is the key to unlocking their full potential. Generative AI relies on different architectures depending on the media it produces. 1. GANs, or Generative Adversarial Networks. 2. Neural networks, generator and discriminator train in tandem. The generator creates, and the discriminator evaluates. Together they iteratively improve. Real-world use GANs are used in fashion to generate new clothing designs based on current trends and user preferences. 2 neural networks, generator and discriminator, train in tandem. The generator creates, and the discriminator evaluates. Together, they iteratively improve. GANs are used in fashion to generate new clothing designs based on current trends and user preferences. VAEs, or variational autoencoders, encode input data into compressed representations and then reconstruct it. They are great for creating variations of existing content while retaining style or structure. In the medical field, VAEs are used to simulate MRI images and predict future abnormalities. Diffusion models start with pure noise and iteratively add structure to produce coherent images or audio. They require high computational power but deliver detailed, realistic content. Applications like Midjourney and Stable Diffusion use these models to create high-resolution artwork from written prompts. LLMs are built on the transformer model, a revolutionary architecture in machine learning introduced in 2017. Core concepts in transformers: self-attention, which understands context by relating each word to every other word in a sequence. Embeddings, which convert words into numerical vectors that capture meaning and usage, and layer stacking, which uses multiple attention and feed-forward layers to deeply understand context. Training pipeline: massive pre-training, which involves reading large portions of the internet, books and articles. Massive pre-training involves reading large portions of the internet, books and articles. Instruction tuning refines the model to better follow human-written prompts. Alignment via RLHF uses human feedback to rank and reward helpful, harmless, and truthful responses. Example: ChatGPT's ability to provide safe, non-offensive replies comes from RLHF processes, where human evaluators scored responses over months of training. Generative AI and LLMs shine in different domains, although their applications often complement each other. In education, for instance, generative AI can be used to create engaging three-dimensional diagrams, interactive models, or animated lessons that visualize complex concepts. Generative AI and LLMs shine in different domains, although their applications often complement each other. In education, for instance, generative AI can be used to create engaging three-dimensional diagrams, interactive models, or animated lessons that visualize complex concepts. Meanwhile, LLMs offer adaptive tutoring, generate essay prompts, provide feedback, and help explain concepts in a conversational format. In marketing, generative AI might be used to produce branded visuals, video content, and catchy jingles. LLMs complement this by generating persuasive ad copy, slogans, product descriptions, and SEO-optimized blog posts. This collaboration results in full-fledged campaigns built with both visual and verbal elements. In the software industry, generative AI is capable of producing wireframes, user interface prototypes, and even three-dimensional user environments. LLMs, on the other hand, support developers by generating functional code, auto-completing scripts, explaining algorithms, and documenting APIs. In healthcare, generative AI assists by producing synthetic medical images for training or diagnosis simulations, while LLMs simplify clinical notes, write reports, and translate complex medical terminology for patients. Finally, in the gaming industry, generative AI helps build immersive environments, textures, and character models, while large language models are used to write rich storylines, dialogue trees, and in-game documentation. The synergy between the two technologies is evident. Generative AI handles the visual and auditory components, while large language models manage the textual and narrative aspects, together enabling seamless and scalable creativity. Using generative AI, designers can prototype product ideas without needing a three-dimensional artist. Artists can speed up concept art, storyboarding, and background design. Filmmakers can create pre-visualizations and storyboards before shooting. Musicians can generate instrumentals or mood-specific melodies. Case study. A YouTuber creates thumbnails using Midjourney and adds animated intros generated by Runway ML, cutting post-production time in half. Using LLMs. Freelancers can draft blogs, emails, and client proposals on demand. Educators have the ability to tailor lesson plans based on individual student needs. Executives can automate business communications and internal documentation. Researchers can generate summaries of technical papers, saving hours of reading. Case study. An independent app developer uses ChatGPT to code app components, write FAQs, and generate customer onboarding content. The intersection of generative AI and LLMs is growing rapidly. Prompt engineering. LLMs are used to write more effective prompts for generative art models. Synthetic media AI-generated avatars use LLMs for realistic dialogue. Narrative world-building. Combine DALL-E visuals with GPT-generated storytelling to develop immersive games. These hybrids are the foundation of multimodal AI systems, tools that can see, hear, speak, and understand. Generative AI challenges. Data licensing. Many models are trained on copyrighted material. Ethical concerns. Deepfakes and misinformation can erode trust. Hardware demands. Video and three-dimensional generation require expensive GPUs. LLM challenges. Factual errors. LLMs can confidently present incorrect or outdated facts. Bias propagation can reinforce harmful stereotypes if not carefully tuned. Opaque reasoning, LLMs cannot explain their logic, complicating trust and auditability. Both types of models must be deployed with transparency, oversight, and responsible data handling. Future AI systems will be natively multimodal, meaning they will understand and generate across all media types, text, images, audio, and video seamlessly. Emerging trends, unified interfaces, tools like GPT-4 and Gemini that integrate chat, vision, and voice. Embodied AI robots powered by generative models to understand language and perform physical tasks. Interactive agents AI that books appointments, creates content, and collaborates in real time. These systems won't just answer questions or generate images. They will perform tasks, make decisions, and collaborate on human goals. Generative AI and LLMs represent two powerful dimensions of machine creativity. One gives us visual expression and auditory innovation. The other empowers thought, language, and logic. Together, they unlock entirely new workflows for education, business, entertainment, and personal growth. If you learn to harness both, you're not just using a tool, you're building with a collaborator. The pen and the paintbrush are now powered by silicon, but the vision, that still comes from you. Drop your thoughts in the comments, and don't forget to like, subscribe, and hit that bell icon for more insights on AI and technology-related topics.